Hello, beavers. Okay, so this is going to be a little bit of a different kind of a video. The lesson I need to do today, I really need to use my computer. I really wish we were there in front of the board and we could actually see it, but we can't. So we're going to try to do it this way and see how it works. So we're looking at decimals this beginning now. We're still working with fractions because fractions and decimals work together. But we are working with decimals, and we have 1/10, which is our fraction. And when we have decimals, our decimal point 1, any number is in the first column after the decimal point is your tenths, okay? And that's what we're looking at right now is our tenths. So, and bear with me because you know how when I try to write with this, it doesn't always look so beautiful, but we're going to try. Okay, so it says shade the first 4 units of the tape diagram. So we're going to shade them. Again, it doesn't matter. It's not going to be beautiful. 1, 2, 3, and there's 4. Okay, so we have 1/10, 2/10, 3/10, 4/10, okay? So when we write that down here to go along, we have our number line has a 0, and then our number line has a whole, okay, which is 1. So we have 1/10. After 1/10, we would have decimal point 2. Yeah, that's beautiful. Which would be 2/10. Y'all know how it is when I try to draw with this computer. I wish I was at the board. So there's 2/10, right? So we have 1/10, 2/10, 3/10. Then we would have 4/10. I'm trying to go quick, but you know how it is when I'm writing. 4/10. So decimal point 4, which would be 4/10. And then after 4/10, we would have 5/10. And then we would have 6/10. And then we would have 7/10. And then we would have 8/10, 9/10, and 10/10, which would be when we have 10/10, it would equal 1 whole, right? We know that from our fractions. 10/10 would equal 1 whole, okay? All right, so let's look at our pictures. We have illustrations. This is write the total amount of water in fraction form and decimal form. Shade the last bottle to show the correct amount. Okay, so on our bottle, we have our number line. This time it is going up and down, but it is the same thing as if it was going from side to side. If it was from horizontal or vertical, it doesn't matter. Remember, we did number lines like this a while back in the year. Okay, so same thing. 1 L, 1 liter, that would be 1 whole. And then 0.5, that is 5/10. So this would be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, which again is 1 whole. So they want us to describe what the liquid is. So if that's 5/10, 6/10, 7/10, which is decimal point, that's a pretty decimal point. Decimal point 7. Wow, I need my eraser and I need to try that again because that was not pretty. Okay, let's try that one more time. Decimal point 7. That looks much better. Okay, 7/10. That is our tenths spot. Okay, let's look at our second one. Again, we have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, which is 1 whole. So 5/10, 6/10, 7/10, 8/10. I guess once I'm done with these videos, I'll be able to write nicely with this mouse. 8/10, which is decimal point 8. 8/10. All right, so this last one, it wants us to show, it gives us the amount right? Which is decimal point 3, which is 3/10. Let's see, 3/10. If we have 3/10, is it going to be down below 5/10 or be above 5/10? Below 5/10 is exactly right. 3/10. Let's see, that's 1/10, 2/10. 3/10 would be, about there. So if we were going to color, my coloring skills, Miss Pritchett needs to go back to kindergarten. Whoopsie. That is just beautiful. Wow, coloring with the mouse is not very hard. I mean, not very easy, excuse me. Ooh, that's pretty. So 3/10. All right, let's look. It says, write the total weight of food on each scale in fraction form and decimal form. So we have broccoli and lettuce. Hopefully we're eating our vegetables, and hopefully we're eating our fruits. Oh, I love lemon in my water. And we have bananas and apples. I like Fuji apples. They're my favorite. Okay, so we have broccoli and we have lettuce on the scale. And it's 0.7, decimal point 7, which would be 7/10. Okay? 7/10. It says write it in fraction form or decimal form, which they already have decimal. Oh, they want me to write it there. They already have decimal form right here, 7/10, because decimal point 7, that's in our 10th spot, 7/10. All right, let's look at our scale over here. We have 6/10, which is decimal point 6. Because right after the decimal point, that is our 10th spot. Okay, it says write the length of the bug in centimeters. Drawing is not to scale. So that's not really how big a little, I guess that's a ladybug or beetle, is. Okay, so they want fraction form and decimal form. Okay, so if we're looking through our little magnifying glass and we look and where 1/10, there's our whole, right? Which would be 10/10. There's our 0, which would be 0/10, right? Our 0 would be 0/10, which would be nothing. And our 1 whole would be 10/10, which equals 1 whole, right? So in between 0/10 and 10/10, we have all of these, and our midpoint would be what? Exactly 5/10, because halfway between 0 and 10 would be 5. So this longer part would be 5/10, which I think if we go up, his head is probably right there at that 5/10 mark. So that would be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10, which would be 1 whole. But his little head, if I go up, if I could draw straight, I think his little head would be right there at the 5/10. So fraction form, we have 5/10. Decimal form, we have decimal point 5, which equals 5/10. If the bug walks 5/10 centimeters farther, where will its nose be? If it is on 5/10 now, and it walks 5/10 of a centimeter more, then it's going to be on 1 whole, which is our 10/10, right? So it would be on 10/10, which equals 1 whole, so it would be 1 centimeter. Ooh, that's a pretty M. All right, so it says fill in the blanks to make the sentence true in both fraction and decimal form. We have 4/10 plus blank equals 1 whole, which was 1 centimeter. So 1 whole would be 10/10, right? So if we have 4/10, we would need what more? 6/10 is exactly right. 6/10 more. 3/10, we need a whole. If we have 3/10, what do we need to make a whole? 7/10, exactly right. I can hear y'all in my head, by the way. Okay, if we have 8/10, we need a whole again. We need 2/10 more. Perfect. And I know y'all saying the answer is quicker than I'm writing, but this is hard to write. Okay. Decimal point 4. 4/10, exactly. So if we have 4/10, we need a whole 1 centimeter. 1 whole. We have 0.4, right. We need 0.6 more to make that whole. If we have 0.3, again, we need a whole. Oh, you're right. We need 0.7 to make that whole. All right, we have 0.8. I need another whole. We need 0.2. You're exactly right. Y'all are so smart. 0.2. Wow, that's beautiful. Hopefully y'all's handwriting's looking a lot better than mine is today. Okay. Ooh, match. Let's see if I can make a straight line. I bet I can. Okay. So here it says match each amount expressed in unit form to its equivalent fraction. Ooh, equivalent. What does that mean again? You're exactly right. Equivalent means they are equal. And it's equivalent decimal. They're all equal. Okay, so we have 2/10 equals 2/10 equals 0.2, decimal 0.2. 4/10. Where am I going? I'm going up. 4/10, which equals 0.4. Well, that's not too bad. 6/10. Wow, we're going to go down. And 6/10. Wow, I got to go all the way up. Okay, ready? Ooh, there we go. Okay. 7/10. So I got to go up. That's not so bad. And 7/10. Oh, I got to go all the way down. All right, ready? Oops, I almost hit 5/10. 5/10. Where'd it go? Oh, it's in the middle. There we go. I should have used different colors. And then 5/10. There we go. Now it just looks like a big spider web. Beautiful. All right, so that's going to be the beginning of our first lesson with decimals. And this is our second lesson with decimals, and I'll be putting all these pages up there for you. So it says for each length given, draw a line segment to match. Express each measurement as an equivalent mixed number. Okay, so Miss Bridget's not going to be drawing the segment. I'm going to show you in a minute what it looks like, but there's no way with this pen that I can do that. But I'm going to show you the equivalent mixed number. Remember, your mixed number is a whole number and a fraction because here they have 2.6 centimeters. So we would have 2 wholes, and that would be 6/10 centimeters because it's in our tenths spot. So 2 and 6/10. Yes, that's equivalent. I got to break it down. Oh, I got to write it again. Okay, so that's 2 and 3/5. It's equivalent, right? Okay, so we have 3 and 5. So 3 wholes and then 5/10. 3 wholes and 5/10. 3.5, which is, yes, equivalent to 3 and 1/2. That's exactly right. Okay, now we have 1.7. That's equivalent to 1 and 7/10. Can I break that down? No, I can't. There's nothing I can divide or multiply. Well, I could multiply. Nothing I can divide the top and the bottom by to make it smaller. All right, 4.3. 4 and 3/10. Again, 4 and 3/10. Again, nothing I can make that smaller. And then we have 2.2. That's 2 and 2/10, which is equivalent to, can I divide the top and the bottom by 2? You're exactly right. So it's equal to 2 and 1/5. Beautiful. Now I'm going to show you what they want you to draw. You'll be glad I didn't sit here and draw it. That's what they want you to draw. But I can't draw that I can barely write numbers. Okay, so it says write the following in decimal form, then model and rename the number. So here they have, each of these has 10/10. Okay, each of them has 10/10. They're broken into 10 equal parts. So they have 10/10. So we have 10/10, 20/10, 30/10, 40/10, 50/10, because we have 5 and they're broken into tenths. All right, so we need 2 1s and 6/10. So we need 2 holes. Again, this is not going to be pretty. Let's just color like that. Ooh, Miss Tedford's going to say, Miss Bridget needs to go back to kindergarten with her coloring. That's just beautiful. All right, so there's a hole. And let me try to make circles this time. Circle, circle, circle. Wow. There's 2. And then, okay, I'm going to have to pay attention this time because I only need 6/10. So I need, I'm not going straight. Wow. Y'all just don't know how hard it is to draw on these little things. I need to be up on my board. So that's 3/10, 4/10, 5/10, and 6/10. And yes, I was actually trying to make straight lines. So that would be 6/10, 2 holes and 6/10. 2 and 6/10, which equals 2 holes plus 6/10, 2 plus 0.6, 2.6. 2 and 6/10, 2 and 6/10, okay? Whether you're writing it as a decimal or writing it as a mixed number, they are equivalent. You're meaning the same thing, okay? Now, 3 1s and 8/10. Whew, okay, 3 1s. So there's 1, there's 2, there's 3 holes. Woo! And, oh geez, 8/10. I like this next one. They only want me to do 1/10. Okay, so they want me to do 8/10. Okay, ready? 1, 2, maybe if I go faster, 3. Oh, nope, that's not working. 4. Oh, 5, 6, 7. Ooh, 8. Ooh, I didn't mean to go. I went over a little too far. Okay, so 8/10. So 3 holes and 8/10. So we would have 3.8 or 3 and 8/10. Means the same thing. 3.8, 3 and 8/10. Okay? 4 and 1/10. Oh, 1. Let's just call that 1. 2. Let's just call that 2. 3. Wow. 4. I think I might be famous on YouTube just for my coloring. That's 4 and then 1/10. Let's see if I can just color 1. I'm trying. Oh, 1/10. That looks not so bad. Not going to say good. Let's just say not so bad. Okay, so we have 1, 2, 3, 4, and 1/10. That's 4.1. That does not really look like a 4. It kind of looks like a Y. I know. Don't be so judgmental. It's hard. Okay, so 1 and 4/10. We need a hole and then 4/10. So it'd be 1, 2, wow, 3, 4/10. 1.4, which is equivalent to 1 and 4/10. That is 1 and 4/10. Ooh, 33/10. Gosh, 33/10. What is that equivalent to? That's equivalent to 3 and 3/10, right? 3 and 3/10, which would also be written as 3 decimal point 3, right? 3 and 3/10. So we would need 1, 2, 3, and 3. 1, 2, 3/10. All right? And I didn't read my question. Let's go back and read my question. How much, I was concentrating so much on drawing with my pen. How much more is needed to get 5? Okay, so if I have 1.4, 1 and 4/10, I need to get to 5. Well, let's see, how much more will we need to get that a whole? to make a whole, we would need 6/10, right? If we had 6/10 more, then we would have 2 wholes, right? So to get to 5, we would need 3 more wholes. So we would need 3 6/10 more. All right, let's look at this one. How much more is needed to get to 5? All right, let's look again. We have 3/10. To get to a whole, I would need 7/10, right? So if I had 7/10 more, then I would have 4, right? So I would just need 1 7/10 more. All right, go ahead. I'm going to put the pictures of the pages up there. This is not in the math book that you have, remember. But work on the picture. I'm going to put the pictures up there for you and then work out your problems. I'll see you next time.